Example 9, a cart has a curved surface with a deflection angle of 45 degrees and is hit by a horizontal jet of water with a diameter of 40 mm and a velocity of 20 meters per second. The cart is prevented from moving by means of a horizontal spring attached to the vertical wall, causing the spring to be compressed. If the stiffness of the spring is 1,600 Newton per meter, determine the compression of the spring in mm, the force exerted by the wheels, and the work stored in the spring. So for number 1, Fx is just the force in the spring is equal to spring constant times the compression in the spring, K delta x or Kx. Then this is the situation. We will call the x component of the dynamic force as Fx, Fy as upward, and we have V1 20 meters per second since there's no frictional loss and the cart is held from moving, so V2 will also be 20 and the angle, deflection angle is 45 degrees. Then we have force in the spring which is equal to Fx and wheels, reaction on the wheels. So for number 1, Fx is q rho quantity V1x minus V2x. Remember, this is now curved. Then Fx is also spring constant times delta x, the compression delta x, or x, simply x. So we equate q is pi area 0.02 square times velocity 20, density 1000, quantity V1 is 20, V1 or V1x is 20, V2x is 20 cosine of 45, then equals spring constant 1600 delta x. So delta x is in meter for this case, 0.09202 meter times 1000, so delta x is 92.02 mm. For the second part, the force exerted by the wheels, summation forces y equals 0. So Rw plus Fy equals 0. So Rw equals negative of Fy. So assuming Rw is upward. Where Fy is q rho quantity V1y minus V2y. So negative of q rho quantity V1y minus V2y. Where V1y is 0 because the jet initially is horizontal. V2y is 20 sine of 45. So substitute Rw is negative of pi 0.02 square times 1000, quantity 0 minus 20 sine of 45. Since this is negative, negative is positive, so Rw must be upward. 355.4 newtons. Then number 3, the work stored in the spring. Stored in the spring is 1/2 of spring constant times quantity final displacement square minus initial displacement square, where the final displacement here is 0.09202. The initial is 0 because the spring was unstretched when the jet is not yet hit on this curved surface. So 1/2 of 1600 quantity 0.09202 square minus 0 square. So in Newton meter, 6.774 Newton meter.